Hello friends, how are you? So welcome to Code Careers YouTube channel. And today again we are going to solve another problem regarding binary search. So here my problem is finding square root. Square root. You might have given some value like function like that, and in function parameter is an any number. You have given any number. Okay, for that you have to return actually, for that you have to return square root of that particular number. So here I am means some example like you have given like 25 any number, so it has complete I think whole square root. Okay, so it has 5 complete square root number, but some number might have like 26. So for that also I'll return 25 only, because I am means we will return only whole number, floor of the number, that way. Okay, so you can think accordingly. So like, because number can means number might be any type of any number, might be any whole number. Okay, like 26 27, for that we don't have this complete whole, square root for that particular number. It will be like a 5 point something. So I'm not calculating a fractional square root number. We are going to return only whole number this way. Okay, so first thing, and other, how we can solve this problem in nav approach, simply already might know like because what I any number if you have given like number. Okay, in number like 25, and is for that square root, surely square root, like I can assume like square root of that particular number is x. So surely x will be less than 25 and greater than 1. Okay, so it means if I can start calculating square of number from 1 to 25, 1 to 25, surely I'll get any number that that's square, like that way. 1 square, 2 square, 3 square, I'll check in loop, and at the end surely some number will be that have square of that number equal to or less than, near equal to. Okay, 25 near equal to number actually. Okay, it means x square sure is less, will be less equal to 25. Okay, x is square root of this number. Okay, x will be less equal to 25 and greater than 1. Okay, so here means a simple nav approach we can follow this way only, means writing for loop checking for each number from I barabar 1 to dot I barabar 1 to I less than. I can write properly here. I equal to 1 to I less than. I can write I less than number only. Okay, and I plus plus. Simply nav approach we can check, and I can if I into I somewhere if found equal to number, I can return. I can return, but sometimes we will not get actually I into I is equal to number, but somewhere I'll get okay, I can write some other way also, like it's because any some numbers passing in parameter, for that we don't have any is complete square root of the number. Okay, so for that I need to check around, I need to return around uh, around that square root. Okay, like I have x is equal, I can create int variable, some variable, and int x. Okay, it's equal to some any number like 0. Okay, for because it's method variable, I need to initialize with any value. So if I into I is equal to number, surely we can return. But if else if I into I into I less than number है, so we can keep updating this number. X is equal to, okay, here also I can write actually some variable, assign variable value to the variable. Okay, but here I can directly return actually. I don't need to actually assign this variable, keep assigning, keep updating this variable, because I found complete square. Okay, that's why. Because here I need to assign, because I am updating this variable, because sometimes I'll get, for the example wise, like I have 27 number, 29 number. Okay, 20 for 29. Sometimes I'll get I is equal to 5. For that square will be 5 square is equal to 25, but it's not equal to number. So here it is less than number, so I can assign actually I into I in this variable. But after that, when I comes to 6 5 square, so it I will get here 36. So 36 actually is greater than, when another thing I can also write here, else if another is else if, where I can compare I into I greater than number, so I can break this loop. So I don't have to means iterate till the number actually. Okay, because if I it comes greater than means there is no square root for that after that. Okay, so I can return simply here at the last, I can return x only, because x had been assigned already with square root of that number that is near about around that square root. It's not equal to complete square root, because 29 don't have any, have actually fractional number, square root fractional number. But as I'm not calculating fractional number, so I directly return whole that is 5 only for that. Okay, so I can return simply this way, return x. So this is the NAV approach. Here again we can optimize something. You can think little bit here, because for any number if you find like I have 4, 5, 6, I can I think remove this. I 4, 9, 16, 25, 36, any number if you get. So for these all these numbers, if you divide by 2, this has 4 has 2 square root, 3 has 9 square 9 has 3 square root, 16 has 4 square root, 5 square root, 6 square root. All these numbers if you see, 4 has 2 means, and I can assume here n is, these are n. Okay, if you do n by 2, n by 2 means all numbers, either all square root of that these numbers either equal to n by 2, or it will be less than, mostly less than only, less than n by 2. If you see for the 9, for 9, 9 by 2, because it will come I think to 4, around 4.5 around, so it is less than n by 2. This is also less than, this is also this is also means every number for each numbers any number if you see, but for two actually you can see exceptional that have equal to, otherwise any number don't have equal to 1 by 2 square root. Okay, this is actually equal to square root of n. Otherwise don't in any number don't have, means for any number if you see always and square root will be less than only square root n by 2. Okay, I am not writing I think properly here. I can say this way square root of any number always will be either equal to n by 2 or less than n by 2. Okay, so I means here as I'm iterating till the number I don't means I don't need I think so I can simply write here n by number by 2. I don't need to iterate till the number. Oh, surely here also you can see I create written break means I break the loop here when I into I greater than number. So these ways somewhere you can optimize in nav approach also. If I'm not doing here break and returning in the end of the ending of loop, so time complexity will be increased because number might have some larger okay value. Now I'm going to optimize more because as you know I am working on all problems related to binary search. Okay, so now comes to binary search, how I can apply here to calculate this square root using binary search. Binary search also have same these three conditions I need to add. Okay, so binary search how can I can apply. You can think I what I am doing here from one to iterating loop one to one two dot number till the number I am doing sir binary sir wait, I am doing loop here. So these are you know as you know these are sorted in a sorted order surely because I am doing from the start beginning not skipping any number and from 1 2 3 4 dot that way we are doing here. So these are sorted because condition follows binary search. And other thing what I'm doing because from 1 to like I can assume here 25 number is there, 25 number is there. So surely you know in square root will be inside between means square root will be any of these numbers either 3 4 5 any number will be square root of n number n num. So I can search actually run in binary search way. So I can assume like if I can find out mid first from 1 to 25 mid will be something so that number I can check either this that mid some I come like mid comes here like and 1 plus 25 by 2 13. So I can check here either 13 into 13 is equal to number or not. Okay, so these way we can do use binary search. And I have already means I think told you multiple problems regarding binary search, so it is I think very much easy from the other problems. So I'm removing, I can go with other tab actually. So how I can write code for the binary search. I have given int n. For that I need to calculate I need to for that I need to calculate square root. So as already I tell you, st surely will be from started from 1, and ed will be n by 2, I can assume. And I don't have to means in binary search also to calculate from the last, because number will be inside, from inside and 1 to n by 2 only, means between these two numbers. Always for any condition square root will be between 1 to a square root, I can assume if x, so it will be less or equal to n by 2 or greater than 1. So I can do binary search in between only. Okay, from 1 to 1 n by 2, ed n by 2. And uh, and one variable I need to take again, for as I already in iterative approach, sorry, in nav approach I did it like taken a variable like x that have in initial value have 0, because here I am means update keep up, I will keep updating for fractional. Sometimes if n is a fraction number, so near is nearest is square floor of square root I will written here. Okay, square root value. So I can simply in binary search, if you see already means I have told you multiple problems, so I can same way I can do here st less equal to ed equal to, why I'm doing equal to, because I've already proved you 4, any 4 is for 4 we have 2, that is square root for 4. So that is equal n by 2 equal to, it is in equal to actually square root of 4 equal to actually n by 4 by 2, that way we can say. So it is equal to, so that's why I need to use equal to condition. And other thing I can tell you, like base condition you can also use, like if n is equal to 1 or n less than less equal to 0, that way you can return you can calculate right here base conditions also. Base condition you have to remember always, because in interview these are checked, or for if you are doing hacker rank test something, so test cases will be failed for that. Okay, I'm not telling, actually I'm concentrating on only logic only. Okay, here. So that way, and here I need to calculate int mid is equal to st plus ed. Int mid is equal to st plus ed by 2. Mid is equal to st plus ed by 2. And here I need to, I can calculate in beginning only, like square int, I can take another variable int sq is equal to mid into mid, because I have to use multiple places this variable, that's why every time I should not, I think, calculate is multiplication. So if I can you write here condition, if sq is square root variable if sq equal to n, if sq equal to n, so I can directly return here, there is no issue. Return what I can return here, sq mid, I can return here mid. And else if sq, if sq is less than, if sq if sq greater than, first I can compare first greater than, I think no problem, anything I can do less than or greater than. So sq, if sq less, square root value is less than actually number, less than number. So what I need to do, because it exists. It means square value exists after mid actually. Square root value exists after mid. It not exist before mid value. Okay, so it means I need to increase as increase st is equal to as st is equal to mid plus 1 I can do. St is equal to mid plus 1 I can do here. And else, for else what I can do, and other thing, because sq is less than n, so I have to actually initialize, update my this variable in answer variable. Okay, x is equal to s is equal to mid, because if it is like that condition, I had already checked for 5, a number was 25 27. I had checked here in this condition, 5 is equal to mid is comes here 5. 5 square will be 25, but 25 is not equal to actually n because it's less than n, but it's near to 27 only. I don't have any other number that have a square root, or that have square of equal to 24 27 value. So I have to keep in this variable, this value in actually result. So that's why I have to update here, because in next condition it comes to else here. Okay, it comes to else, it means it is mid exist in left side of the left side actually. So here I can do ed is equal to mid minus 1, and I can return. I Because loop had completed here now, at the last this position I can return x. Here I had written already mid. I don't have to. Okay, sometimes is there any place where I need to return minus 1? I think every number have a square root. For 2, if you see, if you are passing 2 value, so I don't have any square root for that 2 number. So I can, I think we can maintain this for 1 2. I can maintain, and for 3 also. For 3 also we can maintain. These 3 numbers I can maintain here in base conditions. Because for 3, if you see, if I you have number 3. Okay. So what I'm doing here, from 1 to 3, 1 to 3 binary search. Numbers comes, sometimes numbers comes 1. So 1 square, there is no, 1 square is equal to 1 only, so I can calculate actually for that. So these number you can handle in base conditions. Okay, so this is the solution of finding square root of any number. And another problem I have, because I have some time, so I can go for another problem. So I should go for next tab, I think. Okay, so I have another problem to search any number in infinite array. You have given infinite array, or other word you can say any array, any array, for that you don't have size. Okay, yeah, you don't know size of the array. Both way you can say, or any other way you can say, any problem, like you have an array that have lot of numbers, like large size of array you have, like 1 million or 1 billion record, that way. But such number, somewhere, it exists left side around. Okay, here on, between here to here might exist. So you don't have to search from here to here actually. This is not good idea, I think. So in this case also you can use binary search. In this case also you can use this concept, some solution only that I will tell you to search element. You know also, if for this case, if you know also like size, what is the size, you know it is 1 million size, but you again you also know like a number surely will exist from left side only. So I don't have to search in complete whole array, 1 million record. So we can optimize some complexity, time complexity. Okay, binary search, whatever I'll use here same only, there is no changes. You can use a previous whatever I told you, any binary search, previous means lectures binary search, that only you can use, simple only. But main target here to tell you like how I can do apply, how I can apply binary search, because here in binary case searching, you know I need two variables, from start variable something and end variable. But here end I don't have. So if I had calculated end, so I think is very easy to use binary search, there is no issue. Okay, and I'll not miss again here tell you what is the binary search. I'll only tell you how I can calculate end actually. Okay, so what is the basic approach, nav approach? I think there is no nav approach, already I have told you. To search the element in nav approach, simply start from beginning to end. It is so simple as that, already I have told. But for it calculating end, what I can follow here, if I need to calculate in, how many ways I can do first thing. So first way I you can do randomly, like st I can start from, I can start loop, and where st will start from zeroth index, and ed I can choose any some constant value, cons value, something like 1000. In between, in between you have, you will, and I can assign const here, ed plus is equal to con. That way you can do here, and est will be, so I don't need to do this way, so I can assign directly 1000 in the beginning case. And I can do calculate, like I can do apply, I can do apply here binary search between 0 to 1000. If number is found, so I can surely I can return index of that number. But if didn't get here, so I can again, it means I can assign st from 1000 ed plus, I can do here st is equal to ed plus, st plus is equal to ed plus 1, because 1000, for 1000 I've already done. And ed, what I can do, ed is equal to, ed plus is equal to cons. That way you can do apply, and every time st will be updated, ed will be updated, and you are going keep taking interval. You can, you are taking chunk of the array. So first chunk will be 0 to 1000, and other chunk will be 1000 1 to 2000, and other chunk will be 2001 to 3000. That way you can keep searching, keep applying search. This is also best approach, what I think. Okay, if you know array is larger size, have larger size, okay, then I think it will be very much easy to search on, applies binary search. But other approach, What is the other approach? What I'm actually here telling you, or for that I will provide the solution also. So this is here in this approach. If you see, I have not calculated in actually. I've taken simply constant variable. But in another approach, I'll calculate in. How I'll calculate in? But if I'm doing whatever I'm doing to calculate end, if I am doing here log n type something to find to calculate in, then there is no use of using binary search, I think. Okay, so it means whatever I'll use here to find in end variable, I'll use less than n or something around log and complexity code. Okay, log and complexity code. So how I can do? I'm thinking here I can start. I, as you know, I have array something like that: one, two, three, four, five index, zeroth index. I can give also like dot. So for zero, I can use it in this index value. I can use in base condition actually, and I can start from here. I can do like first I'll check for one. I, if I've taken I is equal to 1, so first I'll do while loop and keep updating is equal to I into 2, means multiply by 2 every time, I into 2. This way I can, if I'm doing actually what I'm doing here, searching acts actually searching this sorry function, and whatever I have function in searching like int, I have given num variable. Okay, num. So here what I am doing here, I have to search this num in this way. I is equal to I into 2 every time, not for every index. If I am doing for every index searching, then it is I think a linear case or nav approach will be, and you will get surely number variable. But in this case, if you are doing I is equal to I into 2 index incrementing in loop, like that I can write also your code while array I less than num, that way, less than num, or is in the beginning I can take I is equal to 1. This is the code to calculate end. At the last, end is equal to, you can assign this end I into end variable. Okay, so st already you know, st started from 1 and ed will be I. Okay, so what I'm doing here, first in the beginning I is 1, then I will be 2, then will be 4, then 8, then 16, then 32. I'm not doing linear case here. I'm not comparing with every index values. I'm doing this way: 1, 2, 4, 8, 16, 32. It means it is for that. If you calculate, so you'll get log n type something, log n type complexity in this case. Okay, so it means for calculating end, I am taking log n something, log n times something. And what is in n here? And you can assume anything, like, because if you have large, I have 1 million record, and if it is exists left side of something, left side of array or right side of array, it depends on the actually number, this number where it is existed. Okay, you can use here k also, k something. So you, if you find here, if you find here end, here end is equal to I and st if you get, so it means you can apply directly. Now you can apply search, binary search directly. And because for the end, okay, no problem. I think I can directly apply for this end also. And other thing, One thing also I can tell you, like some places I number were like 1000 that I had to search. Okay, 1000 or a little bit here also I'm only I can use here 16 number. Okay, number was 16. So ST here ST also I'm going to calculate actually. What I'm going to calculate ST because ST also I should not I think start from the 0 or 1 something somewhere. Why I can tell you here. In any case like num was 16. Okay, for that number was 16 that you have to search in any array having numbers 16 or something 1 million record have. So for example I can use some 16 and then I think I can use 20, I can use 30 20. Okay, after that I can use 32. It is not consecutive numbers, it has some dot, okay, and 40 something 50 something dot, then after dot. So what why I'm taking I because I need to calculate here st. So some cases when you were doing while array I less than num I is equal to I into 2. So in some case I was eighth index. For that you had calculated eighth index, you had calculated 8 in 8 for eighth index. Yeah, I can assume eighth index having 8 only value. Okay, and after that 16 index if you found somewhere 16 index, but 16 index. Okay, value I can here I can use some other cases. What I had taken values here, don't need to take actually same. I can take 18 like that. Okay, 18 like that. So I need to search actually 18 I have 18 value. Okay, I need to search 18, either 18 exist or not exist. So in one case I was at eighth place at index having value 8 only like that, but after that index comes to 16. 16 means this place. If I'm keep I means updating some start st variable also like at the st, because if I got it like st was I was at 8th place 16th place, and somewhere when I found after 16 directly I goes to 32 places 32 values. It means, and I know already here when I was there in this position, so value was greater than, value was not less than actually. This value 16 is not, 16 value is less than actually than the number. It means this number exists after that, after the 16, after the 16. So if I had already assigned st is equal to 16. Okay, and when I comes to next index like calculate directly 16 to 30 32, I comes to here 32 place, and it becomes greater than the number that I need to search. So it means I found end variable, I found end variable, ed variable. So this is the ed, and I don't need to, because it comes greater than, so I don't need to update this st. So st will be updated while array I less than, array I will be less than number. So it means, and other thing st, when comes to st, so I can start st, I don't need to take st from the beginning only, because I here also if you calculate some larger case complexity will be increased. So to optimize this complexity also you calculate st variable also. St will be 16 or ed will be 32. So between 16 index and 32 index you can apply binary search. You can apply your binary search. Simple is that. So simple is that. How much here you can think how much we have optimized. So I can go for the code I think directly, and you if something missing, you will surely you will understand there. And binary search for calculating square root I'll do later on, but for this I can I think sorting searching here I can do new class search in infinite array. Here I can take actually infinite array, so I'll take here something int array is equal to element having some values like in sorted order surely should be sorted order only 2 4 5 7 9 10 12 13 14 15 18 like that you have some values and 120 150 like that. Okay, you have this area but you don't know the size. I'll pass search function. So okay, one thing I can do int res is equal to I'll call function search function search in finite. Here I will not pass actually array length. Okay, and I don't calculate array dot length also. Okay, here I will not calculate array dot length for the end. If I will calculate, so it means I know the array length. Okay, because here in this is the case where I don't know the length array length. So here I need to calculate the length of the array. St also I will calculate. So st I can create a variable in the beginning also. Beginning only st is equal to 0 int pd is equal to I can take -1 path, not 0. Initialize and first I have to calculate int or st. So I can use while loop and for the variable purpose what I can take here int variable int I can take int I only I can take no problem. And in the for the base case I can tell you for base case surely you have to use, otherwise because number might be exist in zeroth index also. So if array zeroth index is equal to num num array I had passed here and again other int and k number that you have to search. Okay, and instead of using n you can use k. So if array 0 and here you have to pass search element. So what I can pass here 9 I think 9 I can pass. First I will search 9 either 9 exist or not exist. Okay, so k I if array 0 is equal to k, so I can directly return zeroth index. Okay, I will start I from 1 first index and to check array index out of bound. Array index will not come actually in infinite array, so I don't need to handle this case actually. But yeah, but you can handle using try catch. You can handle using try catch. Try because your code should not break. If in array index out of bound exception comes some places, so it means somewhere your I was at that in was it is in this index, and it comes after and next index when you do multiply, it comes after that array. So it means you have to, but if you are taking this in value is as an end variable, so I think somewhere you might be number, this k might exist in after this variable. Okay, so it means you have to go somewhere. So I think from if somewhere you got exception, array index out of bound exception, so you can increase one by one, I think. You don't need to calculate do multiply by 2. You can here in this catch place, you can search by doing linear case. Okay, you can apply a linear case. How you can apply here? Because you know our previous I. Okay, so for that you have to yeah. So for that LED you are updating in ST. So I'll do later on. Okay. First I'll complete here while loop. This one. Catch catch case also I will here handle. Okay. There is no issue. So here what I'll do here, simply I'll do array without any fear. I can do simply array I, if array I less than a searched element k. So I can keep updating I is equal to I multiply by 2. And before doing I is equal to I, before doing I is equal to I multiply by 2, I can hold st is equal to, I can update st is equal to I. Okay, st have taken I because in this case st in when I had I is equal to 1 and loop this condition was true, that's why I came to this place. It means number is not exist before index k. Such number is not does not exist before index, index I, I. Okay, it means I can use start as I for now, but later on I'll keep updating st also. And I'm keep doing I is equal to multiply by 2, and keep doing some places when some places when I comes when I get in array index out about exception, means previous at st place when I had st some value, whatever I have st value, like example 15 I had. So in this case there is no exception, and searched element not does not exist before 15, means it exists after that, this after 15. So here in this case you can directly apply in catch, or you can use your flag variable for catch case, or you can write your code inside catch also. For catch you can do another int j is equal to st, or I can do, I think here while loop, I can apply while loop. While array, while array st less than search element के I can keep updating st, or I can do, because I don't know end. End actually I don't know. So because end I don't know, somewhere it comes index out of bound exception, and again here in this place again index out of bound exception will come. Sure, 100% it will come, because end I don't know and I'll keep updating st. But if in number does not exist, then only exception will come here, otherwise exception will not come. But in real case you have to handle actually this, here also you have to handle this case. Sorry, I did here actually. So here again you have to use try catch, because if you need to handle case that one also. So you can keep doing st searched element if st not equal to, you can do array st not equal to k, then you can do st plus plus, keep doing st plus plus. And at the end, if there is no exception comes, means array st comes to k somewhere else, so you can directly here return st. And if exception comes, so you can return minus 1, because number does not exist, such number does not exist in array. I'll test here this test case, okay. And I have done everything in cache. Now comes to here, and st I have already, and ed you can update again, ed because I not updated, so ed will be if exception doesn't come, and somewhere array I comes to greater than k, so that array I comes to greater than k, greater than k, that I will be index in the variable, okay. End I can use. So it means value can be exist at end variable. End can exist or not. I think end will not exist less than or equal to. If I had checked equal to, then only. But I have not checked, so it means number it so can be exist in ith index and or at st index. St what I taken here, st previous value, so it can be exist in st also. So simply here now I can call here binary search, binary search, or you don't need to return here in 0 at the last, you can return this binary search only. This done binary search. Here I need, you have to pass array comma st comma ed. So simple is that. In binary search, you can reuse if you have already code, or you can write here again code. But I think I have, but I don't know where I have, because I not taken naming convention. I have not taken properly. That's why it is very difficult to find out. Search infinite root, square root. By taken left occurrence test, count occurrence. Binary search I should have, I think. Search. ओके, नो प्रॉब्लम। अब तक तो मैं कर देता, इसको इतना टाइम नहीं लगना चाहिए इसमें, ठीक है। मैं लिख ही देता हूँ कोड, कोई प्रॉब्लम नहीं है। सो आई कैन अप्लाई हियर डायरेक्टली st और ed I you have already and while st less than ed less than ed not less equal to, because such number can be exist in place of st or ed also. Okay, this way. At the last you have to return -1 if you didn't get, but surely you will get because I have already checked. That's why -1 you will not get any time in this case. You can check here int mid is equal to st plus ed by 2. Okay, and you can check if array of st array of mid is equal to k. You can simply return mid variable, else if array mid is less than array mid is less than k. So you can update here. Less than means a left side of the mid it exists. So I can update ed is equal to mid -1. Okay. Else you can tell st is equal to mid plus 1. Hmm. So here I found -1 actually here. Why I got it -1? 9 it exists here. So I can calculate debug one time only. I'll get what is the issue here. Okay. I'll check here. First I'll check here what is the ST and ED. Then after that I'll check other thing. Debug is, so what is the ED value? For now I have -1 and go down assigned value I. So I, okay, fourth index. I come to 4 index. 0 1 2 3 4. Fourth index directly. How I calculated I? I was at the beginning 1, 1 into 2, 2, 2 into 2, 2 into 2, it should be 2 to 4, and 4 into 2, it should be 8. It should not be a 9 actually. I should not be 9 any place. Okay, okay, what 2 into 2, 4 comes to 4. Okay, that's why. 1, okay, that's why it comes to 9 directly because 0, 1, 2, 3, 4. That's why. So because first place in first situation I had 1, then I 1 into 2 2, 2 into 2 4. Yeah, there is no issue. It's fine. I think. ST, what is value I have? ST I have 2. So it means there is no issue. I think here ST 2 I have and ED I have 4. So value will exist at index between or same between or equal to, I can say, not between directly because it can be existed st or ed. So I had used here st less equal to ed. There is no issue. Mid calculate st plus ed by 2. I'll do here again where I have done wrong thing. Somewhere I found 3. And if array mid is equal to k, I can return here. Or if array mid less than k, so in the otherwise mid plus 1, I think it is fine, no issue. So for in this case, mid is equal to 3. It's not fine. I think it will comes to else place. So I can check here by doing one iteration and again iterate. So now st is still 2. St not updated. Okay. Else array mid what is the value for the mid and st. Oh, this is the wrong condition I had used. Array mid. If array mid, actually, why I actually have written wrong. K, that way I should written here. If k value is less than or array mid, no, sorry, no issue. If array mid value is less than k, mid is less than k, it means I should increase here, but I had here it decrease mid. Okay, that's why st I should update here st actually because value it exists after the mid actually. Because k is greater than I should use that way condition, that it should be better I think. If k is greater than this one, k is greater than array mid value, then it means k exists after the mid. Okay, so st will be st plus 1, and other else case mid will be ed will be mid minus 1, that way. That is the wrong, otherwise everything was fine. So I can remove debugger or I can, I think, stop. And you got this answer. Okay, fourth index. You can change here another value 13, or you can use I think 15 you can use here. And if you do search 15, you will get some 9 index. You can calculate 0 1 2 3 4 5 6 7 8 9. And if you do other case, if you do like 120, you are searching for 120. Let's check here either it comes to index out of bound or not. I'll debug actually. No, I will not debug it. I can write a print statement I think to check, because debugging will take time. And this one I can take here also. Yeah, minus one I will return. There is no issue for that. You can see here exception comes here, but answer also come here 11. You can calculate 11 is fine or not. 0 1 2 3 4 5 6 7 8 9 10 11, 120 comes to 11 place. But this is the case where I comes to index out of bound, because you are doing multiply by 2 every time. Somewhere I comes to here, but after the multiplying it surely it will goes to out of the array. Then that way you can handle, I think it will help you very much. Okay, so now other problem what I had, other I had for calculating square root. I think I had already code. I can show you if I have. I don't know. So this way, I think square root. I have square root. Okay, square root already I've told you, na. What are the problem that I had? Square root problem only. Okay, so square root base case I think I had not handled here, but base case you can handle your own st I had used linear case already. You know how you can use linear case, but for the Barney search case, you can use st is equal start from the two, and ed will be surely num by two, because I have already told you why I should take num by two. St less than num. Simple is that. So simple is that because mid and you can calculate mid. I have already. I can show you here also. Same. This is same. I had written st is equal to 1, ed n by 2, and x is equal to 0, and mid I had calculated, sq is calculated same way. This was the solution. So you can use this code also. What I did here, st I taken 2, I can take here 1 also. I think there is no problem. I can start from the beginning. Why I had not used 1 actually? Because square root will be always will be less great equal to greater equal to 2 and greater than 1. I told you already, square root will be greater than 1. I am calculating from greater than, because for 1 you can calculate 1 square is equal to 1 only always, and I am not calculating fractional here square root value. So I am doing here व्हाट आई एम डूइंग हियर, बट आई हैड यहाँ पे मैंने यहाँ पे नहीं किया हुआ है वो चीज़, ठीक। तो यहाँ पे एक काम मैं और कर सकता हूँ, इंट आर ई एस इज इक्वल टू आर ई एस रिजल्ट इज इक्वल टू आई कैन यूज हियर सम वैल्यू -1, आई कैन टेक हियर -1, ओके। एंड you have to update actually if else case square comes to number equal to, so is surely you can return directly, no problem. But when else if square is less than number, so some possibility is there, like this number is square root. There is a possibility, I can say it is sure, because in I have already told you some cases like n is equal to 27. So for this square root will be calculated like 5 only. 5 only will return. I will not return 5 point something. I am not here calculating equal to directly. So for any number that you are passing parameter, the if it doesn't have complete square root value, so for that I need to take previous square root value is previous square value for any mid, previous square value for any mid that have less than value less than 27. So for this actually, for this case I have to assign this mid here. I have to assign result is equal to mid here. I'll here again I'll do, I can do here 27 directly, 29 you can do here, okay. If you do here 29, you can see what will be the result. Answer I can do here. Okay, I have not written here result actually. I should result return a result value, and I think somewhere it goes infinite. Why goes to infinite? Okay, st, while st less than number. Why I did here number? St is equal to ed. Why while st less than ed made st plus ed? I have to check actually, because I think it has multiple bugs here. Mid is equal to st plus ed, square is equal to mid into mid square, if number equal to number st ed, calculating, no problem, I think it's fine now. So square root of 29 is 4. Huh? Why it's 4? Square root of 29 is 4. Let's square to verify, it comes to 16. So why it has written, why not is 25? Okay, I'll check here. Square is less than, it means it doesn't in. Okay, as I have to check less equal to condition. Now it comes to five. Okay, you can see here because I not use equal to condition. That's why answer was coming wrong. So square root of 29 is 5 only. It's not 5 point something. You can check for the 5 value, square value of 5 is 25. But here you are searching, you are means calculating square root for 29, but it's written for the 25 only. Why it's happened? Because of this line only. Okay, otherwise you will आपको यहाँ पे, अदरवाइज यहाँ पे आपको कोई आंसर प्रॉपर नहीं मिलता अगर हमने ये लाइन नहीं ऐड किया होता, ठीक है। तो ये इसका बहुत इंपॉर्टेंट केस है यहाँ पे, ठीक। यहाँ पे आप कोई भी वैल्यू आप पास करो, 27 के 37 यहाँ पास कर दो, 37, और 37 की जगह पे इसका स्क्वायर रूट क्या होता है, 6 × 6 36 होता है ना। सो इट विल रिटर्न 6 ओनली है, 6 ओनली, यू कैन सी। ओके, थैंक यू गाइस, सी यू नेक्स्ट लेक्चर में। और लाइक शेयर सब्सक्राइब जरूर करें, और अगर आपको पसंद आया तो शेयर भी करें वीडियोस को।